Hello everyone, welcome to Engineering Archives. Let's look at our practice problem number 6. So this problem says, if the resultant force of the two tugboats is required to be directed towards the positive x-axis, and Fb is to be a minimum, determine the magnitude of Fr and Fb and the angle theta. Alright, so there are a couple of conditions in this question. The first condition is that the resultant force, these two forces, the resultant force of these two forces has to be horizontal in the direction of positive x-axis. In other words, the resultant force has to be somewhere along this line. Alright, so Fr, or the resultant force, has to be positive, has to be along positive x-axis. The second condition is that Fb needs to be minimum. So in order to achieve that, the length of this Fb vector has to be the smallest. And is there any other condition? No, that's it. Okay, so from the first condition, what do we understand from the first condition? So if the resultant force is along the horizontal x-axis, that means that it has no vertical component, or it has no component, or no net component along the y-axis. In other words, the y components of the 2000 Newton force and the Fb force have to cancel each other out. And to cancel each other out, their components along the y-axis need to be equal in magnitude but opposite in direction. And they are opposite in direction, as we can see in the diagram, since the y component of the 2000 Newton force is upwards, while the y component for the Fb force is downwards. So that's the first thing that we see. These components need to cancel each other out in order for the resultant to be only horizontal. Okay, so let's write an equation that says just this, right? So 2000 sine of 30 degrees, this is the y component for the 2000 Newton force, minus Fb sine of theta, this is the y component for the Fb force, has to be equal to 0, right? And let's just rearrange this. So in other words, as we can see from this equation, that the y components of both the forces are actually equal in magnitude. Alright, now let's move on to the second condition. Fb needs to be a minimum. So in order for Fb to be a minimum force, what has to be the angle that it makes with the positive x-axis? Now normally I would say that if the axes that they have given you are perpendicular, you don't need to draw a vector triangle. But for this question, for the sake of explaining it properly, I would like all of you to look at a previous problem that was pretty much similar to this one. And I believe that was a practice, that was a learning question. Yeah, this one. So as you can see, this question had almost, yeah, they had the similar conditions, and they wanted us to find the force F2, and the force F2 had to be a minimum. And for it to be minimum, we came to realize that it has to be directly downwards, because if there was any horizontal component added to F2, then its magnitude would become larger, right? And similar to this diagram that they have made right here, I'm going to make another diagram so that you can understand this more easily. So to draw a vector triangle for this question, just for the sake of understanding, let's draw the resultant first. So if our resultant is horizontal, like this, and we already know the vector for the 2000 Newton force, which is like this. And now for FB, we say that it is the shortest or it's the smallest if it's directly downwards like this. But let's say, what if FB is not directly downwards? What if it's a little bit slanted to the left or to the right? So what if our triangle is instead like this? Well, you can clearly see that this should be smaller than this. I know I've drawn this triangle a little bit smaller in size, but just imagine that if this triangle was the same size as this one, then this length would be larger than this one. Similarly, if our triangle looked like this, if our triangle looked like this, you can see again that this length is larger than this length. And the reason why any slanted length would be larger than a directly downwards FB is because a directly downwards FB only has one single downwards component, while a slanted FB has a downwards component and a left component or a right component. And so they add up to give you a resultant FB component that is slanted, right? So that is why FB needs to be directly downwards. Okay, so if FB is directly downwards to be shortest, we know that theta needs to be 90 degrees. So theta needs to be 90 degrees. Now that we know the value of theta, we can simply substitute the value of theta into this equation that we have, and we can get the value for FB. So FB equals to 2000 sine of 30 divided by sine of 90 degrees. Instead of 90 degrees is just 1. So FB is equal to 2000 sine of 90, and that gives us 1000 newtons. Alright, so we have found the angle theta, we have found FB. Now all we need to find is the resultant force, or FR. So since the force FB has no horizontal component, so the only horizontal component that will contribute to the horizontal resultant force is the horizontal component of the 2000 Newton force. So in other words, FR is just equal to 2000 cos of 30 degrees. This gives us 1732.1 newtons. Okay, this problem is not hard, but it is a little bit tricky, and you should read all your questions carefully, and you should practice this sort of questions a little bit more, and then you will get the intuition as to how to solve problems that put forth conditions like this problem. Thank you very much. See you in the next video.